This is immediately way stiffer than any of the other materials that I've tested in these videos so far. All right, guys, today is the one you've all been waiting for, the Essentium HTN-CF25. Now, this is a high temperature nylon. It's a polyamide-based chemistry with 25% carbon fiber reinforcement in the core of the actual filament. They actually extrude this material with a coaxial nozzle. So it's a two-part nozzle with the core of the 25% carbon fiber and a high-temperature nylon sheath around the outside and, of course, in the middle. Now, you don't see many other 25% fill materials because they come so brittle that they cannot spool onto a spool. The HTN-CF25 is the highest strength and stiffness material in the entire Essentium portfolio. Now, the other cool things about this material is that it's easy to process and print, and it's got excellent, amazing thermal resistance. It's specifically designed for tooling applications, high strength and stiffness jigs and fixtures, and as a replacement for light-duty aluminum parts. They actually call it black aluminum. So here's the box for the 2.5 kilogram spool, and this is the box for the 750 gram spools that you'll get when you order them from visionminer.com/materials. Let me open this up real quick and show you. And it comes in this very nice, very thick, metallized, vacuum-packed bag. And it's actually resealable with a Ziploc thing up here. Very, very nicely packaged. Now, even if it comes and it's not fully vacuum sealed, you will have to dry it before you print it. Super important, and you dry this stuff actually really hot, up to 120, 130 Celsius. So regardless, you're gonna have to dry it, but dude, this is some nice packaging, I will say. Let me put this back in here. So by the way, we're doing a comparison video of all the different carbon fiber nylon and carbon fiber filaments, so make sure you subscribe for when that comes out very, very soon. So, and by the way, why would you buy it from our store? We actually give you 3% back on everything you buy, and that can be put towards nozzles, adhesives, machines, more materials, whatever you want. Just another great reason to buy at visionminer.com. So let's talk about where you're actually gonna see this material used in the real world. It's specifically designed for tooling applications, high strength, high stiffness jigs and fixtures. You can even use it for injection molding, blow molding, thermoforming, composite molds, really high strength end use parts. It's literally considered a replacement for light duty aluminum parts. We'll be doing some testing on that in the future. Now, one awesome thing about this material is that when printed solid, it can actually be machined and actually used for injection molding molds. We've got a video on surface finish where they go over some of their other materials, and they actually, Blake shows off some of the parts they made and actually used for a polypropylene injection mold. So if you're tired of waiting on shops to turn around your aluminum molds, this stuff might be for you. By the way, if this information is helpful to you, please hit that like button. It helps the YouTube algorithm know that this info is good and valuable and you want more of it. And you might as well subscribe while you're at it, because we got a ton more of these videos on the way. So let's get right into what kind of machine do you need to print this filament. First of all, your nozzle temperature is going to need to be able to go to at least 270 Celsius all the way up to 310 and higher depending on the speed, which is generally around 40 to 80 millimeters a second on standard machines. On the HSE, they're printing this stuff up to 500 millimeters a second, and that machine is absolutely in another league. So check that out. More info on visionminer.com. As far as bed temperature goes, the standard 80 to 90 Celsius is going to work great. And for bed adhesion, our nanopolymer adhesive actually works fantastic on this material on every surface that we've tested. One bottle to rule them all. Seriously, our stuff works with just about everything except for POM, Delrin, and polypropylene. So grab a bottle if you haven't already. It works better than we ever expected. Let's just put it that way. As far as speeds, again, you're going to go 40 to 80 millimeters a second and faster. And 500 millimeters a second. Think about that. On the HSE, it's an incredible machine with linear motors, and I mean, it's designed to do high volume production, hundreds of parts per day. If you haven't already seen those videos, go check them out. Essentium is doing incredible things in the industry. And best of all, it's made here right in the USA in Texas. Now, as far as chamber temperature goes, it's not required to have a chamber temp. That 25% carbon fill really makes it print easy in open air, but 60 Celsius or more can be really helpful for strength. And as far as drying goes, yes, you absolutely must dry this filament just like almost every other thermoplastic before you melt it. You don't want any moisture in there. It'll really screw up the surface finish and everything. You got to dry it really well before you print it. Now, in regards to drying, we've got an entire kit available on our site, even for the big spools. We now have larger vacuum chambers and ovens coming soon. And that's really all you need, a vacuum chamber and an oven that the spool will fit in. So we actually put together the stuff that we use at our shop so you can do it just as easily as we do. And we also made metal spools so you don't have to worry about melting or warping your spools when drying at higher temperatures or at the end of the filament line when it gets a little bit more brittle. Now, this stuff doesn't have as much of a problem with that as the other carbon fibers because of that nylon sheath around the outside. But let's get right into some material specifications. This stuff has a heat deflection temperature of up to 219 Celsius and a continuous use temperature of 150 Celsius for 20,000 plus hours. Nylon is semi-crystalline and it can be annealed if desired for extra part strength to reduce that internal stress. Let's get into some strength tests. So the ultimate tensile strength on the ISO 527-2 test in megapascals is 148 on the XY, printed like this. It is 74.5 at a 45-degree angle, printed like that. 40.6 on the Y-axis and 24 on the Z-axis. So you still do lose a bit in the Z-axis, but you get an incredible 16,000 megapascals tensile modulus on the XY, 3,500 on the ZX. Depending how you design your part, this stuff is significantly stronger than standard Mark IV style Onyx nylon, which is about 1,400 MPa, but we don't even know what orientation that's actually at. And if you want to know all the other specs and everything else, we've got all the data sheets available on our online store at visionminer.com/data, so you can get the moduluses, the elongation, impact strength, and more by visiting our website. Now let's talk real quick about some specific environmental factors. HTN-CF25 is resistant to a lot of different solvents, making it really great for many chemical environments, especially under the hood applications in automotive. The high carbon content definitely helps the UV resistance, and you shouldn't have any troubles placing these parts outside in direct sunlight for long periods of time, although nylon isn't the best. If you really need UV resistance, we've got a lot of other materials on our site if that's your main concern. Now, as far as electrical properties go, while this isn't a fully ESD safe filament, it's so high in carbon fiber content that it does crawl into the electrostatic dissipative category. Now, we do expect to see other certifications and whatnot, especially from aerospace and automotive coming around, but we'll get to that when it gets here. Now, let's check out some example parts. We've got some parts that we've printed. You might already be familiar with this, which is a motorcycle or bicycle brake handle. One of our previous videos on carbon fiber nylon, I actually showed this off, and this is a regular standard PA nylon carbon fiber. And you can see I can bend it. You can tell I'm bending it there a little bit. Hopefully you can see that on video. It's got some deflection, you know, but I take this one out of the HTN-CF25 and dude, this is solid. Like I can't move it at all. I cannot, it's like straight aluminum. I seriously, I can't bend it at all. I don't feel any movement. It hurts my hands, no good. This stuff is incredibly strong. That 25% carbon, I mean, dude, it makes a huge difference. I'll show you a couple other sample parts over here. As far as surface finish goes, we've got these vases. Now, between these two vases, you'll notice this one is a little bit shinier than this one. And that's because it was printed at higher temperature. One of the things you can do is print in a temperature range, same with our other material, PCTG, and achieve a slightly different surface finish. Now, these vases are hard. We're gonna break these and burn them here in a minute. And it'll be really cool to see how they compare to the other CF nylons. As far as surface finish goes, I'll give you a quick little comparison to some of the other carbon fiber filaments that we have here. Here we've got the sample bars. By the way, if you want one of these sample bars, we do offer these. If you need to test it in your environment or chemicals or something like that to make sure it survives, we can definitely provide these, and give us a call. We'll go over your application with you and send you a couple different samples that might apply to your actual situation. We do have these available. Definitely give us a call. Now, to compare the surface finish, this is the HTN-CF25 compared to the CF-PA6. Now, it's a little bit shinier. I think that has to do with the high-temp nylon that they're using. It does tend to come out with a little bit more of a sheen to it. Now, this is compared to the 3D Tech CF HTN, which is another high-temp nylon, but it's only around 10 to 15% carbon content. And you can see it is more of a matte finish. Compared to CFPC, it is a little bit closer in sheen. It kind of looks like CFPC, but again, still a bit different. So anyway, we'll do a full comparison video on all the nylons and the carbon fibers and everything. Definitely make sure to subscribe so you don't miss that, and like this video if you're enjoying this so far, because we're about to get into the breaking and burning. A couple more parts before I do that. We've got this one right here, which is a jig fixture type deal for manufacturing process. And you can see the surface finish is very nice. Very, very beautiful part and very, very strong. God, yeah, very good. This part here is an electronics enclosure. We printed this in every single material just to show the difference. Video on that soon. And as you can see, it came out beautifully. Hides layer lines pretty well. Different areas where it got hotter, a little bit shinier. But overall, it came out great. The bridging turned out great. There was support material under this, but you can barely tell. There's no drooping, and it looks good. And we just used a single extruder. All these parts were printed on the FunMat HT, and yeah, it came out pretty good. Now, we could probably tune in the overhang area where we did the supports right there. As you can see the layer lines laying on the surface. So there's a little more tuning going in there, but overall, pretty darn good print. Now, as far as these sample bars go, I've got this tensile bar here that I'll just sort of, I mean, that's pretty rigid. Without comparisons, well, actually, let me give you some comparisons real quick. So I've got here HTN-CF25 and PA6. Let's see the PA6. All right, compared to the HTN, it's definitely more rigid. That stuff will go. And the GF30, PA12, definitely more bendy, and the HTN from 3D Tech. In my personal opinion, the HTN-CF25 is much, much more rigid than the rest of these. It's a pretty significant difference. Okay, so let me put these back aside, and let's get into some breaking and burning tests. All I'm gonna do is I'm gonna shove my thumbs into the side of the vase and see how much it deflects before it breaks, and then if it pops back out, or if it molds, or if it breaks down the layers or across the layer lines, and sort of just how it reacts to being squeezed by a 200-pound gorilla. So let's get into it. Here we go. Okay, so we've got some deflection there, pops back out. Oh, yeah, that exploded. Very nice. Oh, God, look at that. So we had a break straight down. This break across the top is not going on layer lines. This break across the top, you can tell because it's got the little points there, and then it goes down at an angle here. We've got a round break in there. Whew, and that shattered. That really went all over the place. And that's a result of the 25% carbon fiber in there, making this very rigid, very hard, more brittle than your average nylon, which is super ductile and just won't react at all. Interesting. That's a very cool break. That's a very cool break. Now at the top here, if I do the squeeze test, oh yeah, way more rigid. Most of the other materials, you can actually squeeze the top all the way together. But this stuff, oh, just breaks. God, it shatters. Look at this. Look at this. That is some rigid material. That is some very, very rigid material. Now, on this one over here, where it's printed a little bit lower temp, the top part isn't as brittle. It's still broke, but not as quickly as the other one. Anyway, very cool. Surface finish is great. Once again, printed on the FunMat HT, available on our website, fisherminer.com. And all we do is high temperature, high strength materials and everything. Now let's break this in the vise. I expect based on that last test, it's going to explode, but I'll just get this down in here. Let's get it secured right over by the logo. Bada bing, bada boom. Cinch it down, and let's see. So I'm expecting this to fly everywhere, but you should be able to compare this to the other videos on other materials where we'll just see how it explodes. This is immediately way stiffer than any of the other materials that I've tested in these videos so far. This is pretty cool. Dude, I'm gonna have to, oh my God, here we go. Oh yeah, all right. This is pretty cool. Looks like we had an isotropic break. Now, if you look closely, you can see there was great layer fusion in there. It broke like a solid part. Now down here, the bottom layer, based on the direction that I was doing it, it sheared off like that. But really good layer fusion. It was a very impactful break. It was a very intense break. It took a lot of strain before it broke. Much, much more than the other materials that we've done. Maybe similar to Ultem 1010. I feel like this was harder than Ultem 1010, like more stiff, more rigid. Interesting, very cool. Okay, so this doesn't have a UL94 V0 flammability rating, but we're gonna light it on fire anyway just to see what happens. Now, for that, before I do that, I'm gonna pull out the Print Pro 2, which is our trusty handy dandy fume extractor. Now this can be put over any kind of open 3D printer or a soldering station, or if you're just burning parts for fun on video, you can soak up all the fumes. We got these available on our website at visionminer.com/BOFA, along with the Print Pro 2 and 3 and 4. All right, so I'm gonna turn this BOFA on, and I'm gonna start with a really thin piece of the vase, and we're gonna just hold the lighter up to it for 10 seconds. And we're gonna see how it reacts. If it shifts or shrinks or burns or smokes, how much it smokes. It's sort of what happens when you light it on fire, direct flame. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, didn't light on fire. That's a good sign. Definitely got droopy, 25% carbon. This is gonna be a cool part after, as soon as it cools back down. Let's see if we can get the light on fire and smoke a little bit more. There we go. All right, we are on fire. We have ignition. Oh yeah, we got dripping too. Definitely got some dripping. And look at that, it's just taking all the fumes, so we're not stinking up the entire studio, but definitely smells like burning nylon, not the most pleasant smell. Ooh, it's still smoking. Still smoking. Whoo-wee, that's some good stuff. All right, interesting. Let's move right along into the thicker part. This is the sample bar we broke earlier. And I'm gonna do the first part on the lettering right here. So we can just see how it reacts, being close to flame. And then I'm gonna try to get this lid on fire too and see how that reacts. So let's do it. 10, 11, okay. Cool, started bubbling, definitely got hot. Started losing a little bit of the details in there. Let's let it on fire. All right, we have ignition. So this stuff will not self-extinguish, unfortunately. If you need something that will self-extinguish, we've got plenty of that stuff on the site. Definitely check out visionminer.com/materials. We've got plenty of these videos explaining all about those. And this is not gonna go out. Nope, that's not going out. All right. Wow, interesting. This really expanded a lot. This bubbled up. It turned into like a bulbous shape, unlike a lot of the other materials where it mostly kept its form. This expanded a lot. Now, if I play around with it, there's definitely a lot of carbon fiber in there. Oh, geez. Good times. All right, pretty cool. Pretty cool. Very good stuff. This is the Essentium HTN-CF25. Very, very cool material, very easy to print, very, very strong, rigid and strong. If you want the strongest carbon fiber nylon parts you've ever printed, this is the stuff. to do it with. Obviously with the BOFA, the spools, the nano adhesive, and the machines and materials we sell, we specialize in high temp, high performance filaments. If you're into that stuff, definitely check us out, visionminder.com. Also, we've got a lot more of these videos coming and full comparisons between CFPC, CFPA, Peak, Ultem, all these different things. So leave a comment down below on what you want us to test. If you have ideas for burning or acids or boiling water or acetone or whatever you want us to do to the parts, and we will definitely take note of those and put those in the next comparison videos. We're doing this all day. Anyway, thanks for watching. Have a positive rest of your day, and I'll see you on the next video.